Hey, welcome back. So, yeah, we've been doing pretty well handling the two-pointer problems, and what we can now do is extend this idea of two pointers to cover a case where three pointers are needed. What we now need to do is, for a given list, we need to find all distinct triplets that add up to 0. We're not allowed to have any triplets where the numbers are in a different position but they're the same. They all need to be distinct. Now, one possible idea that we might be able to use is that if we hold one of the numbers constant and then search for the remaining two numbers that would pair up with that remaining number, essentially then what we have is two-sum, where now with two-sum, we need to match with that number that we've held constant, and all three numbers then would need to add up to 0. What this means is that we're going to apply the two-pointer method as we saw in the previous video, essentially to find a pair, which, if any, will add up to the target value, where now in this case we can see if all three numbers would add up to 0. So one way that we could begin in the first example would be to sort the list. In this way, we are sure that the previous two-pointer method will apply because, if you remember, it assumes that the list is ordered from least to greatest. What we're then going to do is we're going to fix the first integer, -4. We will now search for any pairs that add up with -4 to 0. If we find any pairs, we can add them to our answer. Once we are at the end of our list, then we can say that we found all possible triplets as we have searched in order. The next example is fairly trivial, and as we can see, there's only three numbers here, so we don't have much of a search. Notice as well the three numbers don't add up to 0, and so our answer is an empty array. Going off of the previous idea, notice that in this list, we have three numbers, and they do happen to add up to 0 since all of them are 0. What this means is that we're going to return the triplet 0, 0, 0, and that's it. Finally, what I wanted to do was include an example where you start at -2, and -2 is your fixed value. What you'll notice here is that with a fixed value of -2, there are actually two triplets, and that demonstrates the importance of going inward with the pointers after you've found a triplet. In this way, we can ensure that we capture all triplets with this algorithm. Okay, we should be ready to code now. So let's sort our list of numbers and initialize a list for our answer. Then what we want to do is iterate through our list of numbers up to the third to last number, so that in this way we can consider all possible triplets ordered from least to greatest. Within our iteration, we will skip over any numbers that repeat before we set a fixed value. Once we have a fixed value set, the problem then reduces to two-sum, where the list is sorted. With the remaining list, what we need to do is we need to take our two additional pointers and adjust them until either A, we found a triplet, or B, we fail to find a triplet. If we find a triplet, we will have the pointers go inward in order to ensure that we have found all possible triplets for a given fixed value. We will skip over the duplicate values and also make sure to adjust the pointers inward. Finally, once our list has been iterated, we may return our answer. Notice that because the array was sorted, each triplet appended will automatically be unique. Okay, so what's the time and space complexity of this algorithm? Well, it's O of n squared for the time complexity because our algorithm iterates through roughly the length of the list, and within each of those iterations, it needs to perform roughly n operations, and that would be n by n, which is n squared. The space complexity is O of n because in the worst case, we will need to store all n values from our list. I like this problem a lot as I really feel that this was a nice extension of the two-sum version 2. I would definitely recommend that you check out the previous video on two-sum, and I definitely think that you're going to get a feeling of continuity and accomplishment when you realize that what you've previously learned is actually going to come in handy here. So great job, thanks a lot for watching, and I'll see you next time.